but there's no chance that this script is going to work in an office. No way. I mean, it doesn't work even in my own office, so I can tell you that it doesn't work across. So, which means that we are spending, so it doesn't happen with Python scripts, it doesn't happen with C# scripts, it doesn't happen with Grasshopper. So, which means that we will have to create a cloud-based Dynamo player kind of because we put so much effort into doing these scripts, that I would rather have the non-computational designers to take advantage of them by just playing the Dynamo player, and it does whatever needs to be done. That would be super useful for us.
Yeah, so the last iteration that we had is like for refinery, it started off with Fractal, which is cloud-based. We noticed that having it on cloud is not really like feasible for our customers. That's why we place it on the desktop level. So we did it the other way around. So we tried to evaluate it running on cloud. So it didn't really like meet some of the requirements for most of our customers. That's why we made it available as a desktop version. But yeah, I think that is very valuable feedback. I think if we have meetings with our product teams, is something that we can actually bring up and basically give it as a challenge. So for the next evolution of time.
Absolutely. Thank you.
Thanks.
Now, if you all are willing, I thought I'll take a little bit of a departure, get out of the documentation thing, and discuss something more creative. You know, the whole documentation, the reason why we want to automate is because it's the most boring part of an architecture process. Now, we were discussing about the man-machine kind of interaction, right? At the same time, Patrick also came up the other day when we were talking, he said that he saw a website that says that have a house built without an architect, right? So it simply means that the entire thing is automated, the entire design is automated. There's no need for a designer there. So how important do you think is this man-machine interaction? At what stages do you think it is the most beneficial for us? And then where do you see the industry going in terms of this? Which part of your practice area you think is likely to be affected by a lot of automation? Anyway. Yes.
I think for me, I'm from builders, fabrication. That's why just now I think it's more on consultants, submissions. So I think to touch a little bit based on just now, I think a little bit documentation in terms of construction and fabrication, is the profile design, okay, more complex because you're going to detailing, okay. So whenever there's a change in design, okay, documentation information will be lost. Okay, you need to re-document again. So this is a part whereby the contractors and the fabricators face in terms of documentations. Okay, and then the other thing I think to cover a little bit on using Dynamo, generative design. I think in terms of the contractors may not. Okay, because why? I think we are actually to build, and mostly when we take information, we are not supposed to design unless you are going for a design and build. So the chances is not high of using that, but we can still explore to use to use this software to produce or extract data, or even to analyze things. Okay, but I think at the moment we are not into that. But in terms of if a concern is documentation, for us as a contractor and fabrication, I think it's the design, it's the change is what that kills us. Okay, just like in tenders, when we take one set of drawings, you give us a tender model, drawings and models is different, you see. So what type of levels are we getting in terms of the model LOD from the architecture, you see. So this is only from our part, okay. So I think in terms of, Vinesh, you did mention just now that basing on human, right? Yeah. I think for our part, I can only share that at the moment as contractors, we did explore some of the testing in terms of using smart technologies, okay, that actually in terms of construction safety aspect, okay, in area of the safety aspect whereby in a construction site, every day, everywhere we need safety. We need to ensure safety, and we actually try to deploy smart sensors or technologies along the site, within the site, parameters to actually capture data, just like real-time data, real-time awareness of location base, where are the people, which are the which are the area whereby it's dangerous, that if the data actually sense that somebody is in, something will actually sound out, so or you have to have stop work, something like that. So these are things that we're also working as a contractor base. So we also actually help thinking of that to how can we pull this data back into the model, or the model back data into this type of so-called machines, smart intelligence machines. So we are as a Stretch Construction, I think we are still in the exploring stage to do all this. That's what I can say, that how we can actually make use of smart technology and actually ourselves, okay, because we need supervisors, we need to have somebody on site to actually understand where's the area of danger, and to define this area and use technology to help us to identify, the movement of people around, so that we can actually, in terms of safety aspect, we can actually capture more data at real time. Yeah.
While you were talking about that, what was running also as an idea of this whole man-machine kind of discussion on the construction and fabrication side was, on LinkedIn we must have all seen those drones that lifts bricks and constructs the bricks, right? And then also there is the other bricklaying robot that does bricks on this side. So these are, of course, proof of concepts, not really for consumption. But where do you think is that going on in terms of that man and machine? So on the side, I don't really have to do the hard work, but I sit and monitor the machine that does the work. So where are we on robotic construction?
I think is you need human if you need to make decisions, and there's a lot of changes you need to select, to filters and all that. So those process of where changes are a lot happening all the time is at the early stage. So that's why I think early stage, design stage is more like an Iron Man kind of thing. But when it comes into construction, when things get fabricated, I think we can move into transformers already. But everything just robot.
Do you want to comment on that? Do you think it is possible for us to become transformers during fabrication and construction?
No, because that's happening in the what do you call that? Product
Industrial manufacturing.
Industrial manufacturing, exactly. Because when you design the phone, I mean, of course, you design human design the thing, but when you construct this phone, it's basically all robots.
Oh, exactly.
Yeah. So I think eventually it's going to be. Maybe it's going to be like that.
So how far are we on that technology in Singapore, for example? Where is the research going on? Where do you think is the investment?
I think personally, we may not be there yet. Okay, we just tweet a little bit of these questions. Maybe we ask about if you want to bring a robot in, okay, how is it going to operate? Is it? So in terms of construction, okay, during that stage of construction, the site is messy, right? You got a lot of things that's blocking. So what technology are you actually, going to use to command that robots? Is it? How that robots? You still need a physical person to go down there to operate. So I think at the moment, you can see a lot of prototype outside, okay, that they're using. I think Singapore-wise, we are not there yet. To me, yeah, because in different construction site, you got a lot of wet work. Okay, of course we are doing a lot of precasting, but there's also a lot of supporting element. Okay, so when you're going to bring this robot in, how big, which area, between area to area, how you bridge, how robot actually move. I think all this type of deployment, I think still a long way to go.
But if you ask me right now, I mean, just to add on what you mentioned, in your factory, right? If let's say, because as what Daniel's mentioned just now, a phone is actually can be assembled automatically if, let's say, if it is you're creating a very similar board like for 1 million pieces, right? So in a way we can automate the process. So what I've seen in your fabrication site is that they have basically the models that they have in Revit. So they actually use that model and try to dissect it so that they can actually create your CNC using the.
Okay, I think for this part, just touch a little bit. I think
It's very
what
generic.
yeah, okay, this part is not more onto the construction side, it's more on the fabrication side. It means within the factory. It means that now at the moment, as contractors, we are using Autodesk product, which is Revit, common products, that we can actually have that construction model passed to a fabricator, which is Graveform. Okay, they're actually using precast software. Okay, all they need to do is they take this IFC, select the object, okay, which is all in the form of a 3D object. All they need is to click on the object and say change it to precast. So they need to rebuild the model. They take the object, change to precast, directly they can document it. Means they can start doing all the rebar, detailing, shop drawing. Once you've done the rebar detailing in 3D, shop drawing will come out automatically. And this data will be exported through an ERP direct to machine fabrication. I mean, this is what's happening now. Yeah.
So from a Revit wall, it becomes an actual manufactured wall when it goes to your fabrication yard, right? So I think that is where you can introduce repeatable process. So if let's say portions of the building could be something that could be standardized, and that panels are the ones that you actually repeatedly processed over and over and over, then that's where the automation comes in.
I think as a fabricator, I think we need, it's ideal to have one or a few design that we can replicate at mass production. But I think in terms of Singapore context, we are not able to do that. Yeah, there's too many different,
bespoke.
yes, there's too many different kind of form, even different dimensions. We can't control. It's all based on designers.
I think maybe the issue that is when we are talking about computational BIM, the discussion so far has mainly been about making your existing processes more efficient. So it's the BCA's key focus is efficiency, right? Make it more efficient. But I think one of the key reasons for engaging in computational BIM is to make it more, to do new things that you couldn't do before. It's more innovation, right? So, I mean, when you look at this bench that we're sitting on, is not that the fact that you can cut this with a CNC.
It's not the most efficient.
It's not.
The most efficient bench
It wasn't
rectangular.
because it was more efficient. It was because suddenly, because you could cut this wood like this, and because you could parametrically design it, if you couldn't do that, you wouldn't have designed this bench, right? This bench is like this because it is possible. So the reason that you do this bench like this is not because it's more efficient, it's because it is possible, right? And I think that goes back to this, if the architects learn and understand that there is a process by which you can create a kind of 3D object and it very easily transforms into a precast concrete panel, and that process is highly automated, then architects start playing with that. They start saying, this is interesting, just like, the person who designed this started playing with the idea, these are 2D sheets and you can cut them and it's very automated. Once we understand that there's this process where if you draw something of a certain size and certain constraints and it has a certain kind of limitations to it, but I mean, just like this is limited because it's flat, right? So this is a flat sheet, so we understand that it has to be flat. But you understand those limitations, that drives the creative process to come up with some new stuff that would be very difficult to do in other ways. And so we would see, buildings being built out of precast components that are leveraging exactly that process to kind of maximum, and doing stuff that would be really kind of a new innovative kind of architecture. So I think there's a whole step beyond efficiency that this computational BIM process is really, and that's really when it gets interesting, at least for us as architects. It's like this efficiency story is really boring, right? It's going to save, as office guys, it's going to save them money and all that, but it's not really. that interesting, but it
I
gets
think,
interesting
yeah, we
when
have
we
come to
see
the right point where we would like to pivot and actually ask you a question about this right now. You know, this computational BIM, you know, we have taught a bunch of students, myself included, and I see at least 2 other people in the room who are your students. Now, how do you bridge the gap between how easy or accessible is computational BIM to the middle and the senior management? How do they understand this? How will they kind of get their hands dirty with this stuff? How easy is it to teach them, or should we even try to teach them, or what should they try to learn from this? You know, and of course, by the time we all become senior management, we will either lose touch with the tools or get drowned into contracts. Then we'll forget about this. So, what's your advice for us to keep our fire going?
So yeah, definitely a very difficult question. But I think the approach that I've been taking the last few years, and I think you've also tried to do that in some of the offices you've worked on, is to try and create platforms where you can have different levels of expertise. So within an office, you're never going to get, or you wouldn't want to become, everybody in the office to become a computational BIM kind of person, right? So just like I was talking about this kind of ecosystem, you want in every office there to be different groups of people with different expertise. And one of those groups is going to be a kind of computational group. But that computational group should be able to deliver its impact to the rest of the office. So if you've got an office of 100 people, and you've got 10 people who do computational stuff, it shouldn't be that every time that you want something computational, you go to his desk and say, oh, sorry, I know you want to go for lunch, but can you just help me with this one thing? That's not scalable. So there has to be a platform where these 10 people can create stuff and say, okay, we are an office that does theatre design, and we're always creating this seating, and I've created, me as a computational BIM person in the office has